In part 2 of our lesson on law of cosines, you will learn how to use the law of cosines to solve triangles. In this example, we have to solve triangle ABC. So we know that means we have to start drawing a work surface here. Doesn't matter which vertex we label which letter. Let's maybe call this one A. We'll put the B here and the C here. Now let's label our givens. We know that angle A is 35 degrees. Side B is equal to 7, so that has to go opposite of angle B. And side C has to be 5, opposite of angle C. So, assessing what we have here, we can see that we have two sides and their included angle. So this is that case where we have side angle side, which means we can use the law of cosines. Now the side that we can find here, which is A, we know if we have A squared by itself over here on the left-hand side, then we know that we have to use the other two sides everywhere else. So this would be B squared plus C squared minus 2BC cosine of A. Remember, the A's are like the bookends. If I have side A over here by itself, then I'm going to have angle A as the argument of the cosine. Now we fill in what we know and solve for what we don't know. So A squared we don't know, that's what we're solving for. We know that B is equal to 7, so we'll get 7 squared plus C is equal to 5, so 5 squared minus 2 times 7 times 5 times the cosine of 35 degrees. So now we have A squared is equal to, well, this is 49 plus 25 would be 74 minus 2 times 5 is 10 times 7 would be 70 cosine of 35 degrees. Now be extra careful here. These are not like terms, so they cannot be combined. Occasionally, someone will make that mistake where they think they can subtract the 74 and the 70, but you cannot because these are unlike terms. So to find A, we will have to take the square root of 74 minus 70 cosine of 35 degrees. So go ahead and grab your calculator. To get at the square root, you have to hit second square root, and then you'll put in 74 minus 70 times the cosine of 35. Now you'll need to close the parenthesis of the cosine function as well as the parenthesis for the square root function, and then hit enter. And rounding to the tenths place, we see that we will get A is equal to 4.1, and the units are inches. We can mark that in our diagram. Let's think about our strategy for which angle to solve for next. We'd like to be able to use the law of sines because it's a very quick process. It's just a proportion. Now, if we look at the sides that we have, 4.1 is the smallest side, and we know that angle is acute. 7 is the largest side, and that means B might be obtuse or it might be acute. We don't really know. We just know that angle B is going to be the biggest angle. Now the 5 is the medium side. And remember, we said opposite of the smallest side and the medium side will always be acute angles. So since 5 is less than 7, we know that angle C will be acute. So let's make a little note of that. 5 is less than 7, so that tells us that angle C is acute. Now the reason that's important is because now we can use the law of sines without worrying about the ambiguous case. We only have one known angle here, so that would trigger the ambiguous case of the law of sines. But since we know for sure that C is acute, we can ignore the ambiguous case. So let's go ahead and use law of sines now to solve for angle C. We will get sine of C divided by its opposite side, which is 5, has to equal the sine of 35 divided by its opposite side, which is 4.1. Solve for the sine of C, and we get 5 times the sine of 35 degrees divided by 4.1. We can enter this on our calculators. We get 5 times the sine 35 parentheses divided by 4.1, enter. We get the 0.69948, etc. Let's go ahead and store that in your favorite letter. Maybe we'll put it in A. So to solve this equation, we know we'll take the sine inverse of the sine of C, and that's going to equal taking the sine inverse of that number we just found, 0.69948. We have it stored in memory location A. Let me scroll up a little bit here. And we know that C is going to equal, grab our calculators, second sine inverse, memory variable A, enter, close your parenthesis, enter, and we find out that angle C is 44.4 degrees. And we can label that in our picture now. Now to find angle B, we can use the Triangle Sum Theorem. So angle B is going to equal 180 degrees minus the sum of 44.4 degrees plus 35 degrees grab your calculator and enter that. And we find out that B is equal to 100.6 degrees. And let's get that in our picture. 100.6 degrees. Now we have all three sides of the triangle, all three angles of the triangle, and the triangle is solved. In this example, we have to solve triangle PQR. So let's get that picture going. P, Q, and R. Now we are given that side P is equal to 7, side Q is equal to 8, and side R is equal to 12. Analyzing our situation, we see that we know all three sides of the triangle. When we have side, 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 we know that we can use law of cosines. Remember, we talked about a good strategy to use when you're able to use the law of cosines is to solve for the largest angle first. Because law of cosines does not have an ambiguous case, solving for the largest angle first will let you know right away whether it is an obtuse or acute angle, and then you'll know automatically that the other two, which are smaller, must be acute. So why don't you try using the law of cosines now and solving for the largest angle in the triangle. Pause the video and restart it when you're ready to check your answer. We know that since 12 is the longest side, that means that R is the biggest angle. So let's use law of cosines to find angle R. Now remember how law of cosines works with the bookends. If we're going to be finding the cosine of R over on the right side, then that means over on the left side all by itself, we want to have its opposite side, little r, which would be 12. So we're going to put r squared is equal to p squared plus q squared minus 2pq cosine of r, because the r's have to be the bookends. Now let's fill in what we know. The equation becomes 12 squared is equal to 7 squared plus 8 squared minus 2 times 7 times 8 cosine of r. 12 squared is 144. Here we have 49 plus 64 is 113. Now here we know 7 times 8 is 56, times 2 would be 112, and then cosine r. We would subtract 113 from both sides. Now we have 31 is equal to negative 112 cosine r. Be very careful you don't lose track of that negative sign. It's an important piece. Next, we'll divide both sides by negative 112. So the left-hand side becomes negative 31 over 112 equals the right-hand side, which is cosine of r. We have to take the cosine inverse of both sides. So we'll take the cosine inverse of the left-hand side, which is negative 31 over 112. And that has to equal taking the cosine inverse of the right-hand side, which is cosine of r. The right-hand side becomes r. For the left-hand side, we'll pick up our calculators and input second cosine inverse of negative 31 divided by 112, close the parenthesis and hit enter, and rounding to the tenths place, we see that we are going to get 106.1 degrees for angle R. Put a box around your answer in your work, and let's go ahead and label it in our diagram. R is 106.1 degrees. And remember, since R is obtuse, that means that P and Q are acute. So we will be able to ignore the ambiguous case for the law of sines. So let's go ahead and find angle P. We could do either one, but typically when I'm using law of sines, I like to find the smallest angle. I know that one's going to be acute. So we could set up our proportion here. We know that the sine of P divided by 7 is going to have to equal the sine of 106.1 degrees divided by 12. So the sine of P is going to equal 7 times the sine of 106.1 degrees divided by 12. We can input that into our calculators. We get 7 times the sine of 106.1, close your parentheses, divided by 12, enter. We see that's 0.56045. Let's store that. Maybe we'll put it in B since we just had something else in A. So hit the store button, cursor over under the B and hit enter. Now we'll have to take the sine inverse of both sides. So on the left-hand side, we have sine inverse of the sine of P. On the right-hand side, we are going to have sine inverse of this number that we just stored in B, 0.56045, etc. And we will get that angle P is equal to, well, we come back to our calculators, hit second, sine inverse, memory variable B, close that parenthesis and hit enter, and we find out that angle P, rounded to the 10th place, is 34.1 degrees. Let's put that in our diagram. Next, we can find angle Q by doing the triangle sum theorem. So we get Q is going to equal 180 degrees minus the sum of 106.1 degrees plus 34.1 degrees. Put that in your calculator. And we find out that angle Q is equal to 39.8 degrees. We box it in our work and we put it in our diagram. So now we have all three angles and all three sides, and triangle PQR has been solved.